feel the vibe.
What's up, guys? Welcome back to another Algebra 2 instructional lesson here with Mr. Gaines as we continue our work on Unit 8 in rational expressions. So up to this point, we've done some simplifying, some multiplying and dividing of rational expressions, and today we are going to focus on addition and subtraction of rational expressions. So addition and subtractions of rational expressions follows the same concepts and processes that we had when we added fractions using numbers with integers for numerators and denominators. So I'm going to give you a series of steps, and we're going to walk through these steps in an example and then take a look at a few more examples. So the first thing that we want to do with fractions when we need to add them is find the least common denominator. So the same thing's going to be hold true with rational expressions. So if I take a look at problem 3a, I'm only going to focus on the denominators right now. So I want to find the LCD, or the least common denominator. So if I take a look at the integers there, 10 and 25, the lowest multiple of 10 and 25 would, both those numbers would be 50. If I look at their variables, x and x squared, the lowest multiple of x and x squared is x squared. So the LCD for these two fractions would be 50x squared. So once I identify the LCD, the least common denominator, I need to multiply to the fractions to create equivalent expressions where they're going to have that value for the denominator. So if I need a 50x squared in the denominator for the fraction on the left, 7 over 10x, I'm going to multiply by 5x. So 5 times 10 would give me 50. X times x gives me x squared. But I just can't multiply only the denominator. I need to multiply the numerator by the same value. So essentially, I'm multiplying the fraction by 1. So in doing so, I get the result of 35x over 50x squared. Now I'm going to do the same thing with the second fraction, and in this case, all I need to do is multiply by 2 over 2. If I multiply 25x squared by 2, that's going to give me 50x squared. So I need to multiply the numerator by 2 as well, and that gives me 6. So equivalent expressions getting to the LCD would be these two fractions, and they're still being added together. Once I have found or created equivalent expressions where they have the least common denominator, now I can add and subtract the numerators. So if you remember back from our work with fractions, with real numbers, we would add and subtract the numerators but leave the denominator. The same thing is true here. So I'm going to add together the denominators, 35x plus 6, and then, the numerator I added together, and the denominator remains 50x squared. Now from here, if I can, I want to simplify the expression using our rules. So if I take a look at the numerator, I cannot factor the numerator, and thus I cannot simplify this expression. And so this is how we work through the process of adding and subtracting rational expressions. So first we want to find a common denominator. We want to create those fractions into expressions with that common denominator. Then we can add or subtract the numerators, keeping the denominator, and then we can simplify. Now, in some cases, we're going to want to simplify the fractions before trying to find the LCD. So in the case of 3b, what I see is a denominator of x squared minus 9, and an x minus 3 is my other denominator. Now, some of you may be able to take a look at this fraction, these fractions, and figure out what the LCD is quite quickly. But to kind of go through that thought process, what I want to do is look at the denominator in its factored form. So the factored form would become x plus 3 and x minus 3. That is the denominator of the first fraction. The second fraction cannot be factored, so I'm going to leave it alone for right now as x minus 3. Sorry, not x minus 5. Let's write that correctly. X minus 3 with 5 in the numerator. Now, if I compare those two denominators, I may notice that I can multiply to only the second one in this case. I can get the second denominator to turn into x minus 3 times x plus 3 by simply multiplying by x plus 3. So if I do that, that first fraction remains unchanged. 10x over x plus 3 times x minus 3. My second fraction, I'm going to go ahead and distribute that 5 to get 5x plus 15, so distribute the 5 in the numerator, and I'll leave the denominator in factored form. The reason I distributed in the numerator is now we are ready to subtract the numerators. So 10x minus 5x can be simplified to 5x plus 15 as my new numerator. My denominator is remaining as x plus 3 times x minus 3. In this instance, I may notice that I can factor the numerator. If I factor the numerator, that becomes 5 times x plus 3. And then when doing so, compared to the denominator, I may notice that there are some factors here that I can eliminate. I can divide the x plus 3's here to leave me the final result of 5 over x minus 3. So our original expression that was 10x over x squared minus 9 minus 5 over x minus 3 becomes 5 over x minus 3. Let's go ahead and take a look at another example. In problem C, we have a similar occurrence here with the denominators. One of the denominators can be multiplied to get the other denominator. We can find that again by factoring. So I'm leaving the first fraction alone. I'm not worrying about the numerators at this time. I'm just factoring denominators. Again, the reason I factor the denominator is now I can see the LCD a little bit easier here. I can see that I can multiply the denominator of my first fraction by n minus 2, and that would create me two common denominators. If I do this, the numerator becomes 5n minus 10, distributing the 5 to the n minus 2. And the denominator is n plus 2 times n minus 2. Now that denominator matches the denominator of our second fraction. And once the denominators are the same, I am now allowed to combine my numerators, in this instance through subtraction. So 5n minus n would be 4n. Negative 10 minus negative 3 would be the same as negative 10 plus 3, which is a negative 7. So what I get is 4n minus 7 over n plus 2 times n minus 2. In this case, I cannot factor the numerator in a way that would allow me to simplify the expression. So this is my answer. If you kind of get this process, see if you can pause the video and complete problem 3D. Hopefully you had a chance to look at 3D. And you may notice that again, in this instance, a common denominator can be found by only making adjustments to the second fraction. I can multiply the second fraction by 4a over 4a to give me equivalent denominators. So the first fraction remains unchanged as b squared over 4a squared. The second fraction now becomes 4a times c in the numerator over 4a squared. Because the numerators are the same, I can subtract the denominators. Sorry, because the denominators are the same, I can subtract the numerators, and the denominator remains unchanged. In this instance, there is no factoring that can be done to the numerator, and so this expression cannot be simplified. And there we have our final answer. So this process will extend to even more than two fractions. In each one of these examples, we saw two fractions being added or subtracted to one another. This process can extend to 3, 4, or more fractions being added or subtracted to one another. We first want to identify the common denominator, multiply to get that equivalent expression in the denominator, then add and subtract the numerator if we are able, and then simplify. And this looks like a good place to stop. So when we reconvene in class, we'll have an opportunity to go over questions and do a little bit of practice. As always, thank you guys for tuning in, and I'll see you soon.